Good evening, this is Mr. C, and I decided to record the video of that log equation that I tried to do in class twice today and couldn't do it. The reason I couldn't do it is because I did not write the problem correctly. So here's the correct problem, the correct writing, and now I will show you how to do this very tricky equation. So the first thing that we have to deal with exponential equations is to look at the basis. So we have x here, we have 10, and then we have some kind of exponent. Right now we don't care that there are many things up here. As long as we can get the two green bases to look same, then we can compare these two yellow exponents and solve the equation. This will need a little bit of trickiness. So my problem here is, how do I write letter x as 10 to some kind of power? Now, here on the side, I'm going to remind you about the rules of logs. So if I write, what if I write 10 to the power of log x? Now, if you remember the rule, or here log x, the base is 10. So if you have the same base of the log in the exponent and with the normal base, this just cancels out. So this really equals x. So that means I can rewrite my x as 10 to the power of log x. If you don't believe me, let's see if that's true if we solve that equation. So if I say that this is true, that x equals 10 to the power of log x, well then let's take log of both sides. So I'm going to get log x equals log of 10 to the log x. So in that case, on the left I get log x. Then I can bring down this log x down. So it's log x times log 10. Now log 10 equals 1. So we have that log x equals log x. So this rule is okay. So I'm going to go ahead and rewrite this here as, instead of x, I will say 10 to the power of log x, and then times all this yellow, because that's a power of a power, so we multiply powers. So that will be log x squared to the second power minus 3 times log x minus 4.5. In class I had this thing in an exponent, so that was the problem. That equals 10 to the negative 2 log x. See, now we're getting somewhere, because I have 10 here and I have 10 here, so I can ignore it and just worry about my exponents. So this here in yellow equals that here. So I'm going to write that statement and say that log x times log x squared to the second power minus 3 times log x minus 4.5, that should equal to the negative 2 times log x. I'm going to add 2 log x to both sides. So I'll do log x times log x squared to the second power minus 3 log x minus 4.5, and then I'm going to add this plus 2 log x and set it all equal to 0. Now if I look at my problem, I have log x here and I have log x here. So I could factor that out. So I could say log x times, now what's inside is still log x squared to the second minus 3 log x minus 4.5 plus 2 equals 0. Now let's simplify this. So we have log x times log x squared to the second power minus 3 log x. This here is negative 2.5. All that equals to 0. Well, when something equals to 0 and we have two things multiplied, that means that either this is 0 here, or this whole thing equals to 0. So this is really going to become quadratic equation. So now try to scroll down. Oh, here, page extender. That's too much. So we're here now. So let's see. Option 1, log x equals 0. Well, the base of this log is 10, so we're saying that really 10 to the power of 0 equals x. So 10 to the power of 0 is 1 equals x, or if you like to see it this way, x equals 1. So that's one solution. Another solution here we need to think about and see how can we write this. We're going to be a little tricky here. So we have log of x squared minus 3 log x minus 2.5 equals 0. I would like to rewrite this thing here. Instead of writing that exponent here, just so it's clear, I'm going to rewrite it as log x squared to the second power minus 3 times log x minus 2.5 equals 0. And then we need to think about how to do this, how to deal with this. Well, log of x squared is same like writing log x to the second times log x to the second minus 3 log x minus 2.5 equals 0. Now, using the power rule, we can bring this 2 down. So this is really 2 log x times 2 log x minus 3 log x minus 2.5 equals 0. Now, 2 log x times 2 log x, that will be 4 log x to the second power minus 3 times log x minus 2.5 equals 0. Now we can do another trick where we could substitute log x, call it something else. So I'm going to say that, okay, let log x equals let's say y. Okay, so instead of writing log x, I can go and say 4y squared minus 3y minus 2.5 equals 0. Now here we have a quadratic equation. So we can solve this many ways, but let's do the formula so we could practice a little bit more. So if we use quadratic formula, we need to identify our coefficients. So a equals 4, that's the number in front of the quadratic term, b is negative 3, and c is negative 2.5. So A is 4, B is -3, and C is -2.5. So now quadratic formula, in case you forgot it, says that x1 or x2 equals -b plus or minus square root of b squared minus 4 times ac all over 2a. So let's rewrite this formula, but leave blank space for numbers so you can plug it in, or for variables. Alright, so let's see, we need b, so that's -3, it goes here. We need a, which is 4, we need c, which is -2.5, and we need another a down here. So -3 is +3, plus or minus. -3 squared equals 9. Now here we have -4 times 4, which is 16. I'm sorry, -4 times 4 is -16, times -2.5. Well, -16 times -2 is 32, and then half of 16 is 8, so 32 and 8 is 40, so this will be plus 40. Let me erase this. And in the bottom we're going to have 8. Simplify, you're going to get 3 plus or minus square root of 49 all over 8. We continue, so we have 3 plus or minus square root of 49 is 7 all over 8. So from here on we're going to have two solutions. One is going to be x1 equals 3 plus 7 all over 8, which equals 10 over 8. After we reduce, that's 5 over 4. And then x2 is 3 minus 7 over 8, which is -4 over 8, and after we reduce, that's -1/2. So these are the roots of our quadratic equation. Now let's go back. So these are, well, I said x1 and x2, it's really y1 and y2. So going back to our substitution, we said that log x equals y, and this is our y1 and y2. So we're really saying that log x is either log x equals either 5 over 4 or log x equals -1/2. Well, base is 10, so we're saying that here that 10 to the power of 5 over 4 equals x, or we're saying that 10 to the -1/2 equals x. So these are our options, but what we need to do now is really check. We need to check if these solutions are correct, if they actually solve the equation. So here are the two solutions, and then we had one up there that was 1. So now we're going to check. Well, let's first check for this first one. So wherever we see x, we're going to plug in 10 to the 5/4. So we're saying that 10 to the 5/4 to the power of log of 10 to the 5/4 squared, and then everything squared minus 3 log 10 to the power of 5 fourths minus 4.5 should equal to the 10 to the power of negative 2 log of 10 to the power of 5 fourths. Okay, now I should include one more parenthesis here because that's 10 to the power of 5 fourths and then times all this here. So now we have 10 to the power of 5 fourths times, now this here is log of 10 to the 5 fourths times 2, which is 10 fourths, but then base here is 10, so these two will cancel, so it will just be 5 times 2 is 10 over 4, 10 over 4, but that's going to be to the second power here. Minus, now we can bring that 5 fourths in front of that 3, so there's going to be negative 3 times 5 fourths is negative 15 fourths times log 10, which is 1, and then minus 4.5, and that equals 10 to the power of, now we take 5 fourths, bring it up front, multiply by negative 2, so that's to the power of negative 10 over 4 times log 10, which is 1. So moving forward, we have 10 to the power of 5 fourths times, now we have 100 over 16 minus 15 over 4 minus 4.5, that should equal 10 to the negative 5 over 2. So 10 to the 5 over 4. Now here common denominator is 16. We'll do 100 minus, well, multiply top and the bottom by 4 here. So minus 4 times 15 is 60. Then minus, well, here we need to multiply top and the bottom by 16. That's going to be 16 times 4 is 64 plus half of 16 is 8, so 64 plus 8 is 64 plus 8 is 72 minus 72. That should equal 10 to the negative 5 over 2. 10 to the power of 5 over 4 times, now that's a 16 here. Now we have 100 minus 60, that's 40, and 40 minus 72, negative 32 over 16. Negative 32 over 16 is negative 2, so that's 10 to the 5 over 4 times negative 2 equals 10 to the negative 5 over 2. Now we have 10 to the negative 10 over 4 equals 10 to the negative 5 over 2. And negative 10 over 4 can be reduced, so we have 10 to the negative 5 over 2 equals 10 to the negative 5 over 2. So the first solution works, and you can feel free to go ahead and try the second and third solution to see if it really works. And well, actually, let's do it maybe here. So yeah, let's finish it. So now we need to plug in the second solution, which was 10 to the negative 1/2. See if that works. I'm going to clear this. 10 to the negative 1/2. So we're saying that 10 to the negative 1/2 to the power of log 10 to the negative 1/2 squared, all that squared, minus 3 log of 10 to the negative 1/2 minus 4.5. This is all parentheses, should equal 10 to the negative 2 times log of 10 to the negative 1/2. Let's get rid of this right side first because it seems easier. We will bring that negative 1/2 up front, multiplied by negative 2, so that'd be negative 2 over 2. And negative 2 over 2 is negative 1. So 10 to the negative 1 times log 10. Log 10 is 1. So we're done with this. On this side, we have 10 to the negative 1/2. Now, here, this is, if you look at this here, this is 10 to the negative 1/2 times 2, which is negative 2, or 2, which is negative 1. That's negative 1. So we have log of 10 to the negative 1 squared minus, now we can bring this negative 1/2 up front, multiplied by negative 3, so it's going to be actually plus 3/2 log 10, which is 1, then minus 4.5. So 10 to the negative 1/2 times, now this here is, now this here, we can bring that negative 1 in front of the log, so that's negative log 10. Log 10 is 1, so that's really negative 1, and then squared. Negative 1 squared is just 1, so 1 plus 3/2 minus 4.5. That should equal 10 to the negative 1. Now, this is 10 to the negative 1/2 times, common denominator is 2, so that's 2 plus 3 minus 2 times 4.5 is 9. So now this should be equal. Let's carry out the calculation. So now we have 10 to the negative 1/2 times 2 plus 3 is 5, minus 9, negative 4 over 2. So we have 10 negative 1/2 times negative 4 over 2 is negative 2. And now we multiply these and we get 10 negative 1. Okay, I'm sorry, negative 4 divided by 2 is negative 2. And negative 2 times negative 1/2 is 2 over 2, which is 1. Equals 10 over negative 1. Looks like it doesn't work. Let's make sure that there's no mistake here. So let's go up here. So this here was negative 1. When we bring it up front, it will be -1 times log 10, which is -1, and then -1 squared equals +1. This here will be +3/2 minus 4.5. Everything looks okay. Oh, there's a mistake. So this looks okay, but there's a mistake on this one. So when we brought this here, -1/2 times -2 is +1. So actually, this will be 10 to the first power, not 10 to the -1. So this is 10 to the first power, 10 to the first power, 10 to the first, 10 to the first. So actually in the end our check does work. So the right side had mistake. Then finally let's check for our third solution, which was x equals 1. So if x equals 1, say the 1 to the power of log of 1 squared all squared minus 3 log 1 minus 4.5. Let's see if that equals to 10 minus 2 log 1. Now here's the good thing about log 1. What does log 1 equal? Well, if base is 10, then 10 to what power equals 1? Well, it's 0. So log 1 equals 0. So, 1 to the 0 times 2 is just 1 to the 0. So this here, log 1 is just 0. Minus 3 times log 1, that's also 0. So it's just 1 to the -4.5. And then equals 10 to the, -2 times log 1. Log 1 equals 0, so 10 to the 0. So 1 to the -4.5 equals 1. Well, I can rewrite this as 1 over 1 to the 4.5. Now, 4.5. 4.5 is really 9/2. So we already see that this works, but just for fun, let's rewrite this as 1 over 1 to the power of 9 over 2 equals 1. Well, 9 over 2 is square root of 1 to the 9th, and 1 to the 9th is 9, so I have 1 to the 9th is 1. 1 over square root of 1 equals 1. Now square root of 1 could be positive or negative, so we're saying that 1 over plus or minus 1 equals 1. So in case where 1 over 1 equals 1, that's true. But in case where 1 over -1 does not equal 1, that's not true. So one solution, it works only for principal square roots, meaning positive. And that's it. Now watch this a few more times and do it on your own, and you'll be good on solving most of the logarithmic equations. Have a good night. It's 11:30 p.m. Bye.